what you see here is a schematic of our machine learning overview or machine learning offering. What we've had at DGB and in OpendTect since many years now were the what we call the neural network plugin, which allowed you to do basic unsupervised neural networks in terms of clustering and so forth, and also supervised neural networks where we did example pick sets for features we want to extract from the data, and then combining several different attributes that we see as being useful, we can then extract that information in a supervised manner. Today we're offering the machine learning plugin, as mentioned, and that goes on top of what already was there in the neural network plugin, and this is all now combined into one plugin. So what's highlighted here in blue is what we offer currently under the machine learning plugin, and you can see that the available algorithms has increased quite a bit. Today I will be showing you examples of a simple ensemble learning where we do log prediction from other logs. In this case we will be using this XGBoost type. And the second example I will be showing you is a convolutional neural network where we do Facies classification, and we have different methods of going about that, which I will show you in the demo here in just a little bit. As mentioned, the first example today will come from the F3 demo dataset that we use extensively for training purposes, and which you can also download. You can get all this data yourself and use all the plugins without a license if you wish to try out some of these things that I'm showing you here today. Basically what we want to do is, say we have a well with a poor log, or maybe the log wasn't recorded at all. We can in that case utilize existing logs to predict another log. What you see here in this image to the left would be the row B and DT logs that we can use, for example, as input logs. We have a resistivity log and a gamma ray in the middle here. And then furthest to the right you see the red curve, which is the actual curve that was recorded versus our predicted green curve. This well here in plot 3 here was used as a blind test, so that we can QC the results, and we will have a look at that in the demo here in just a little bit. The other example I want to show you is a convolutional neural network where we take a image, a 2D image or a little 3D kubelet. We extract features. So for this we will need to interpret some positions, example positions that belong to a certain class, that we then use as labeled point sets. We then go through subsampling and convolutions, subsampling again in turn, to reduce the dependency on the exact positions of these points that we have picked. This is basically how this LeNet type of network works that we'll be using in the demo. So we have a few ways of creating labeled point sets. We can of course do manual picking. This we have done already for quite some time now when we did the fluid migration pathway analysis that we do with the supervised neural network. We simply manually pick example locations. For an MLP network this is fine. We usually don't need that many example locations, so manual picking in this case is fine. Nowadays we offer a paintbrush tool in OpendTect where you could pick out more large-scale objects such as salt domes, for example, or just sequences like parallel sequences. And with this paintbrush you're able to then quickly generate larger point sets. Another way of creating a point set would be to utilize the Thalweg tracker that we offer in OpendTect Pro. The Thalweg tracker allows you to, it's a voxel type of tracker where we use the path of least resistance to find the next cell. if you will, and that way map out facies quickly. I will also show you this tool in the demo. The other option that we have is to interpret just regular small patches of horizons on a reservoir scale, if that is possible, and then extract point sets on top of those small horizon patches. And we can randomly generate a set number of randomly picked points along those horizons. And these would be then reservoir scale objects going seismic facies for the convolutional neural network. Today we'll be focusing on the Thalweg tracker, and I will also be showing you how to use the paintbrush and how to extract points along a horizon. In the example I will be showing from the convolutional neural network type of workflow is from the Taranaki Basin of New Zealand. This is a data set that you can acquire. You have to pay the New Zealand government a little bit of money. They will ship you a disk with a lot of nice, good data sets. In this case, we used the Maui 3D dataset that is full of nice turbidites, channels, all kinds of nice, interesting sequences. Our workflow today will be to track 8 classes, so both positive and negative amplitudes. Due to the way the Thalweg tracker works, we either have to stick to positive or negative amplitudes, where we've identified 8 possible classes based on their sort of shape and how they look. So we're dealing with meandering channels, unconfined channels, splays and floodplains and so forth. And we've made sure that each class has 1500 points. So we've taken out points where the Thalweg tracker creates too many points, or we've tracked more points where we needed to. And then we've merged sets if needed, tracked from different seeds. And this is what we get. So this is an example. Stacked channels, we will have a look at this in more detail in OpendTect itself. But basically we've picked out negative amplitudes and positive amplitudes and classes that belong to each. So we have channels, unconfined channels, floodplains, splays. For the positive amplitudes we picked out as well unconfined channels, floodplains and splays. And here to the right you can see in this image we're just showing you 2 slices. We're slicing through this volume that shows nicely these channel facies. And here is some further reading before we get into the OpendTect demo that you can look up on your own time. And now let's get into OpendTect, and I will start our machine learning plugin from this icon here. Again, this will be the demo for how we can use other logs to predict missing logs. Machine learning you can access from here with this little neural network icon with the little plus. In this window we have the option to use either simply wells only, seismic only, or seismic and wells, and our old neural networks, or the tried and tested old neural network workflows, can be found under the 4th tab here. In this case we will go into wells, and I will want to do a log prediction, so I will click on go here. So in this window we need to first select the extract data here. So we select our input data. In the input data we have the option here. You will see that we can also utilize datasets from other surveys that we have in our available. In this case I will use the data from the F3 demo dataset. In this case we want to target a porosity log, and I want to leave one well to be used as a blind test and select the 3 remaining wells and click OK. Next we proceed to select the data. Here we then select what we want to use as input logs. In this case we could use density, we can use as sonic, and we could for example use a gamma ray log, and we click OK. Now these three will be used for the prediction. I'll leave this as default for now. Just give it a name here. Deep Learning Master Class 2021. And click on Proceed. Now we have extracted the data. We will click on Proceed to go into the Train tab. This is, by the way, how the interface looks across all the different methods you can utilize in OpendTect. The dialog looks pretty much the same for each of these. I will select my input deep learning example data, and then for training I will give it a name. So I'll again call this deep learning model master class, and it's preparing currently the Bokeh canvas. Now that the parameters have loaded here, I can have a look through these different options that we have. For the platform, we can utilize either a Keras TensorFlow type or a Scikit-learn. I will leave this at the Scikit-learn. And then we have some other parameters that we can set here. So we will want to do an ensemble type, and for the model we will be using the XGBoost option. So once we've set the parameters here, we simply click Run, and we can follow in these log files. We can see what the machine is doing in the background. This process is fairly quick, so once we read this finished batch processing down here, we can go ahead and close these log windows. Now we are done with the training. We will then click on Proceed, and we will go to apply what we've just done. So now I want to again select the survey that we're in. I want to select the deep learning model that we just created and click on Proceed. For input log for the density, we want to use density, obviously, gamma ray, sonic, and we want to apply this now to the one well that we left out to be used as a blind test. And I will then click on Run. And there we go. Then we get a message saying the log was created. I can then go ahead and close these windows and go have a look at the result in our well manager. So from the well manager, I can select the well, and I can select our actual porosity log and our predicted. And here in the comparison, we can see that we have a pretty good match between the two. And that concludes this demo. Next, we will be looking at the Fascist prediction. For that, I will need to switch my survey to the Maui survey. So here we are in the Maui 3D survey. And first of all, I wanted to show you the different methods we have of extracting these example point set that we will be needing for the following workflow. So one option is to use the point sets as is to pick example locations. So we can create a new point set. We'll call this master class. And I can go ahead and I can pick individual example locations. For example, here. If I want, I can also utilize our new paint can tool. So here, by holding down my left mouse button, I can, for example, pick out this parallel looking reflectors here. I can change the size of the brush and the density in %. And if I paint somewhere by mistake, I can simply hold down Control and paint over again, and it will remove these points. Another option is that we have maybe a small horizon patch that has been conventionally tracked in this case. down here. We can easily generate points along this little horizon patch by going generate 3D, and we generate the locations by horizon. We simply select the horizon we wish to use here. No extra Z needed, we want to stay sort of flat along this horizon. And we can use additional location filters here along horizon. And I will want to create 1500 points. That is the number of points we used for the other classes in this demo as well. So we want to keep that number the same. Right, so this created a random point set along this little horizon. This is one way of creating a pix. The more sophisticated way to do this would be to utilize our Thalweg tracker. I can access that through going 3D horizon, new Thalweg tracker. For the Thalweg tracker, we simply need to select what we want to use to track. So original seismic here. We need to set the start position. We can do that by picking in the seismic itself. But let's have a look first at the schedule here. So in this case, I would like to set something quite large to begin with. So I can start with something like 50,000 points. This will calculate 50,000 points in one iteration. And with the start position will be wherever I pick the start position to be. So we can go down here and we can pick a point along this nice channel here. Now once the Thalweg tracker is done, we can have a look at our channel. So obviously a channel Facies here. The nice thing about the Thalweg tracker too is if I start the tracking at any of these other positions, the resulting channel will look pretty much identical, only the coloring will change because the order of which these seeds were picked that has changed. But I have already done this ahead of time. We can have a look at some of these point sets that I've created already. They will be up here. We have 8 classes, so one for each of these different channel classes that I showed you in the presentation. Example picks. They look like this, and we made sure that each of these classes has 1500 points. We can then go into the machine learning plugin dialog again. In this case, we want to do a seismic body supervised 3D. Click go. And the first thing I need to do is select my input data. So in this case, we want to use the 8 different pick sets that we have picked using the Thalweg tracker. We will proceed to the input data selection. In this case, I want to use the original seismic. And I want to create small cubelets. So for this type of work, I want to create a 20 by 20 by 1 type of cubelet. And then in order to, for each of those points to have a little bit of inlines, crosslines around it for comparison, we would then give it a name here in the output deep learning example data field. I've already done this ahead of time, so I can go ahead and close. We would then proceed to train, and I can here have a look at how these would look for each of these points. So here we have the extracted example point. We can see along the inline, along the crossline. This is only one sample, no, but along the Z slice as well. And then I can slice through these different cubelets and have a look at how they would look. And this, of course, for each of the different collection of points here. So for example, class 2 unconfined channels. And this is a good QC tool as well. Once I'm happy with this, I would then go ahead and train which I've already done ahead of time, and then finally apply this. And we can now have a look at the results real quick. The best way to have a look at these would be in a flattened scene. So I've already created a flattened scene. And there are several ways we can flatten in OpenTect. We can do it along a single horizon, or we can do flattening in a Wheeler diagram, where we would utilize something like a horizon cube to do the flattening. But I can slice in a volume, and I can then observe the 8 different facies that were extracted. And that concludes the demo, and I will now hand it over to Frieza Brower.